Assalamualaikum warahmatullahi wabarakatuh, and a very good day I wish to everyone who is currently watching this video. Thank you for tuning in, and this is our video for our calculus assignment, and our topic is analysis of function the second. So analysis of function the second is actually one of the subtopic in the application of differentiation topic. So we have chosen this subtopic to be our title for this assignment video. Okay, now without wasting any time, let's jump straight into the introduction for this topic. Now, this topic follows the topic before it, which is analysis of function. The only addition is that it introduces asymptotes. Now, what is asymptotes, you might ask? So, there are two types of asymptote, which is the first one, vertical asymptotes, and the second one is horizontal asymptotes. Okay, so the reason that I say that this topic follows the topic before it, which is analysis of function, is because in this very topic, analysis of function the second, we still do the same calculation from the start, which is the first one. We have to find the x-intercept and y-intercept, which is what we have done in the analysis of function. So then we continue to do that, the very same thing in this very topic, which is analysis of function the second. And we also will be going to meet the same thing, which is the intervals, the minimum points and maximum points, the critical points, the concave up and the concave down, which is the only difference for this one topic is this one, asymptotes. So let's continue. Now you might be still wondering, okay, with all that I understand, what is asymptotes actually? So asymptotes is actually a straight line that a graph approaches without touching. It means that this asymptote is what are being used to find the range for the intervals and also to determine whether which one is the increasing intervals and decreasing intervals. And asymptotes also are being used to find out where is the concave up and where is the concave down for the function in the graph. Okay, so for the vertical asymptotes, we have to let the denominator of a rational function equal to 0 and solve it. Then find its analysis by approaching the value from the left and right hand sides. While for horizontal asymptotes, we have to find the limit of fx when x approaches infinity or the function approaches infinity. And then we have to divide the numerator and denominator with the highest degree of x in the denominator. Okay, now let's move on to the problem statement so that we can both get a better understanding for this topic. So the question is as stated, fx equals to 3 minus 2x over x plus 4. And for the first question, we have to find the x-intercept and y-intercept. The second one is we have to find the vertical asymptote and horizontal asymptote. And the third one, we have to find the intervals where fx is increasing or decreasing. And the fourth one is we have to find the intervals where fx is concave up or concave down. And the last one, we have to sketch the graph of fx using the above information.
The first question is find the x-intercept and y-intercept. X-intercept must be y equal to 0. Then you get the answer is x 3 over 2. Then y-intercept must be x equal to 0, which is you just substitute x with 0, then you get the answer is 3 over 4. The next question is find the vertical asymptote and horizontal asymptote. Firstly, vertical asymptote, the denominator must be equal to 0, then you get x is negative 4. Next, analysis of vertical asymptote. We must find the analysis by approaching the value from the left and right hand side. Firstly, limit function x approaching negative 4 negative, we must substitute x with negative 4.111, then we get negative infinity. After that, limit function x approach negative 4 positive, we must substitute you must substitute x with negative 3.999, then we get positive infinity. Lastly, how to find horizontal asymptote. Limit function x must be approached to infinity. Limit x approach positive negative infinity. The function must be divide the numerator and denominator with the highest degree of x. Then you get negative 2. So y is equal negative 2.
So question C, find the interval where function is increasing or decreasing. So first of all, we need to differentiate our function 3 minus 2x over x plus 4 using product rule. And then we got negative 11 over x plus 4 to the power of 2. So the next step is we need to create a first derivative table, which is we are using two intervals. The first interval is negative infinity to negative 4, and the second one is negative 4 to infinity. So we need to test a value between two interval and insert into the function that we just differentiate just now. So I use negative 5 and got negative sign for the interval negative infinity to negative 4, which is shows that the interval is decreasing interval. The next interval we use negative 3 as the test value, and we also got sign negative, and shows that the interval are also in decreasing interval. So we can conclude that both interval are decreasing and none of both is increasing. Next is question D. Find the interval where function is concave up or down. Using function that we already differentiate in the previous question, which is negative 11 over x plus 4 to the power of 2, we differentiate it again and got 22 over x plus 4 to the power of 3. So here we need to use two interval that we already used before, negative infinity to negative 4 and negative 4 to infinity. And we insert the test value and we'll get a new sign for second derivative table. Here we can see negative 5 will produce negative sign, and test value negative 3 will produce positive sign. So the positive one is concave up and the negative is concave down. So the concave up is interval negative 4 to infinity, while interval negative infinity to negative 4 is concave down.
The last question is sketch the graph from the function First, you can see the vertical asymptote is x equal to negative 4 and horizontal asymptote is y equal to negative 2. Then we sketch the concave up and concave down from the question D.
And with all that, we can conclude that asymptotes is the main part of this topic. It allows us to understand more about the graph and how we get to the final graph. The process of finding increasing and decreasing intervals is also another important part, as we get to find more, like the sign of f prime to be negative or positive. And with that, this video ends here. Our explanation ends here. So thank you for listening and thank you for tuning in until the end. Thank you.